Welcome back to Gabversity, ladies and gentlemen, where facts care not about your feelings. It is great to see everybody, and I may even change my sunglasses. Great to see you all. So today we're going to talk about matrix algebra. Actually, the other ones are easier to see. Alright, now what is the point of matrix algebra? Well, I'm going to show you. First of all, it was invented actually by the Chinese. But it was invented by the Chinese about 1,000 years, I think almost 1,000 years before Westerners came up with it. But the Chinese, being very clever, kept it to themselves. so the West had to reinvent it about 8 or 9 centuries later. But we caught up. All right. So if anyone remembers simultaneous equations, all right, I'm going to start with that, and I'm going to show you the point of matrix algebra. Matrices are annoying. Ah, yes, they are annoying, and when you get used to them, they are so much fun. I fell in love with them at the end after doing like hundreds of them. All right, so let us begin. I am going to show you some equations. All right, have a look at this one. 2x plus 3y equals 4. All right, that's one equation. And 3x plus 6y equals 5. So how can we solve this problem? Well, what we can do is, first of all, we can double this whole equation. So this one can come down here, and that can become 4x plus 6y equals 8. Right? That is just double that one. Okay. But now look, we have 6y and 6y in these equations. So now what we can do, exactly, bingo, exactly correct. And so now we can take this equation away from this equation. We can say that minus that, well, 4x minus 3x, right? So therefore x, right, plus 0, because 6y minus 6 was 0, equals 3. Therefore x equals 3. Chromosomes. Yes, chromosomes, that's right. Yeah, this person only has 3 chromosomes. And now we know, right, we know that 2x plus 3y equals 4, right? So that here, because x equals 3, that implies that 2 times 3, because you put 3 in here, 2 times 3 is 6, 6 plus 3y equals 4, okay? So therefore 3y equals 4 minus 6, I just take 6 from both sides, and that equals minus 2. Therefore y equals minus 2 over 3, right? I thought you had to multiply by the negative. You could if you wanted to. There are different ways of doing it, yeah. Okay, so now let's test it in the other equation, which is 3x plus 6y equals 5. 3x, now we're going to test. Okay. Basic system, exactly, that's where we're starting. Minus 6y. Now what I did, right, I took this from this. So 4x minus 3x is x, 6y minus 6y is 0, 8 minus 5 is 3. And then I just put it back into the equation. 3x plus 6y is 5. Put it back in, and we're done. All right, so test 3x, right, plus 6y plus 6, and y equals minus 2 over 3. Right, and let's see what that equals. Well, multiply by minus 2. All right, let's test if this works, right? If y is actually minus 2 on 3, then this, we should get the answer is 5. Oh, don't be sorry, my friend. Don't be sorry at all. So that this here equals 3 by 3 is 9. And 6 multiplied by minus 2 over 3 is minus 4. Minus 4, which equals 5. Which equals 5. Solved. All right. Now, why a matrix is important? Well, I'm going to show you. Because this 2x plus 3y equals 4. What happens if I actually drew it like this? 2x plus 3y equals 4, right? 2x plus 3y equals 4. All right. Now let's rearrange this equation. 3y equals 4 minus 2x. Y equals 4 over 3 minus 2 over 3x. Okay? So if we were to graph this, right, if we were to graph this equation, y is 4 on 3 minus 2/3 x. So 4 on 3 is just up here, and minus 2/3 x, it goes like that. Okay, so that here is this one, y1. Okay, so this line is y1. Now we're getting there. We're getting there. I'm going to show you why this is important. So what I've just done is I converted y1 into a vector. This is a vector, right? Now, which is basically like a direction. Kick my ass in college, drop my grade point average. Oh no! Well, now's your chance, my friend. Okay, here's the next one. What's the other equation? The other equation is this one. 3x plus 6y equals 5. Right? So let's go down here. 3x plus 6y equals 5. Make sure I wrote it down correctly. Yep. Okay, so, right. So therefore, 6y equals 5 minus 3x. Y equals 6 over 5 minus x over 2. All right, so now let's draw this one, which is, right, 6 over 5 is a bit more, is a bit less than 4 over 3, right? And it's minus a half. So it's going to go like this. Okay. Now, what does x equal? X is 3 and y is minus 2/3. Okay. So, what that means, and I haven't drawn this graph correctly at all, but what that means is that, let me draw it again, okay, is that when y is minus 2/3, we'll all have a 4, maybe, or maybe get nothing done. Y is minus 2 over 3, right? We figured out that y is minus 2 over 3. So that means that it's down here, minus 2 over 3, and we found out that x was equal to 3. X equals 3. So that's x, and that's y. All right. Okay. So what is the point of this? That means that this intersection of 3 and minus 2 over 3 is where these two solutions intersect. So they basically intersect like this. Okay, so these are the two vectors and they intersect right here. Okay, this is the point of intersection. Now, why is that important? Well, it's important for heaps of reasons. Because this is only two-dimensional, but wait till we get to 3 and 4 dimensions, which we're going to need for quantum mechanics, right? You want to find out, for example, if you were to pull a car with your bare hands, and you know, and Boss Briggs was to pull a truck with her bare hands, and she's going at one speed, you're going at another speed, and your coordinates are on that map of x and y. Where are you going to collide? You see? So that's how matrix algebra helps us do that. Now, we could just do simultaneous equations, right? Because that's what we just did. But what happens when this happens? Have a look at this. You ready? 2x plus 3y plus 6z equals 0. Okay, and 3x plus 4y minus 2z equals 0. What's going to happen here, right? And another one, 4x minus 2y plus z equals 0. As in Ohm's law. Very cool. Are we really going to do simultaneous equations here on the determinant? Not sure. Feels like a magic trick. I will, but not at the moment. But I will get to the determinant definitely. The determinant, that's actually a bit further ahead. But the determinant is basically the area, or the volume, or the hypervolume of a certain object. That's what the determinant is. Right? Ohm's law, resistance is futile. That's right. So what are we going to do? Are we going to do a simultaneous equation for all of these? Right, that's crazy. So I'm going to show you how to convert this into a matrix. So let's go back to our original example, right? So let's go back to the original example to make it easy. Okay, 2x plus 3y equals 4, if you remember. All right, so that was that line. And the other one was 3x plus 6y equals 5. There it is. You are cool, dude. I try to be. Thank you. Coefficients. Captain Deltron. Always ahead of the game, mate. Always. All right. So what we do is we convert this into a matrix. So how do we do that? Well, like this. 2, 3, 4. And 3, 6, 5. Look at that. So all we've done, it's just notation. We've converted it from this into this. And that's really important because basically all computers run with these matrices. It's so important to have them. Because how else can you add anything? So I'll give you an example, right? These are coordinates. These here, I was touching the screen. Like, why can't you see me? These here are coordinates, right? 2, 3, and 3 and 6, right? And let's say that I want the coordinates of this phone. I have a phone here. I can say that this coordinate is, 0, 0. This is 0, 1. That's like, 2, 1, and that's 2, 0, right? So I can even do that. Watch this. Let's draw around this phone. All right. Now, here is the phone. Phone. Shusalifa? Shusalifa? I have no idea what that is. All right. So, here we go. Phone. Now, if this is the coordinates of the system, right? You're just making up a map, right? You could call this north if you wanted to. That's north and that's east. Phone. All right. There's east and there's north, or you can call it y and x. Doesn't really matter. So here is 0, 0, 0, right? 0, 0. Here is 0, 1. And here is like, I'm just going to call this, you are from, ooh, is that Jordan? Is that the Jordanian flag? I don't actually know. Ahlan wa sahlan. And here we have, let's just say that's, I don't know, 2 spaces, 2, 0. So in other words, that's 2 across and 0 up, right? And this one here is 2 across and 1 up, so we'll call that 2, 1. So now we have a coordinate system, right? And we can use matrices to calculate the area of the phone. And that's important when you have a 3-dimensional or 4-dimensional object, right? Which we have in physics. So that's the whole point of doing this. So how do we figure out these variables doing it this way? Well, now, watch this. You ready? This here, right, I'm going to double this. So I'm going to double the top, okay? Which implies this, right? If we double the top, we have 4, 6, 8, and the bottom stays the same, 3, 6, 5. And why is that important? X2 and X1, that's exactly right, my friend. It's exactly correct. All right, so now we can take away this from this, and then we'll get this. So that implies 4 minus 3 is 1, 6 minus 6 is 0, 8 minus 5 is 3. And the bottom one is still 3, 6, and 5. This is called Gaussian elimination. You don't have to know the name. All right, so there you go. Now, we know already that's x and that's y, because remember we converted it. 2x plus 3y equals 4. 2x plus 3y equals 4. 3x plus 6y equals 5. Microns, no. Are you going to blow our minds? I asked that to my last girlfriend. No, that's a bad joke, sorry. 3x plus 6y equals 5. 3x, 6y, 5. Right? So there it is. So now we know, right? We know from here that 1x plus 0y equals 3, which means x equals 3. Look how quickly we solved it. Right? So just by converting it, see, this was the old way we did it. The old way was having to do this. Look what we had to do. We had to do that, then we had to do that, and we had to do that. 1, 2, 3, 4, 3, 4, 5 lines. Okay? Here, look what we did. We convert it, right, into this, and then by converting it, like, you just do that, and then there's your answer. Is math related to science? Math is the software program that underpins the universe, and possibly stuff outside the universe. Science is a method of thinking. Yeah, you could say that. Math is part of science. Science is a method of thinking, and maths is a law. Yeah. So there you go. You must be Katy Perry with that comment. You never know. All right. So there you go. That's how we solved it. Now imagine if you had a massive equation like this, right? If you wanted to do that this way, right, you would get like 3 pages of mathematics. How's that possible? Well, we don't know how to get there yet, but all signs point to there being many other universes here. All right, that would take like 2 pages, but under this it would only take a few lines. So my friends, there is your glance and acquaintance to matrix algebra. I am so lost in what you are teaching. Did you eliminate a variable? At the beginning of the lecture, I did it through process of elimination. And then what I did there was I did Gaussian elimination, which is using the matrix. All right. So I'll show you one more time. What I did was we converted this into a matrix, right? So 2x plus 3y equals 4, 2x plus 3y equals 4. And here 3x plus 6y equals 5, 3x plus 6y equals 5. So all I did was put it in there, and then, right, I just magnified this one by timesing it by 2. I magnified the whole line. Now if you notice, we did that before here. If you look here, remember 2x plus 3y equals 4, which is the same as saying 4x plus 6y equals 8. Right? 4x plus 6y equals 8. And we did that down here. 4x plus 6y equals 8. There you go. Yeah, George is way ahead. I get that. You've got some experience in maths, my friend. I can tell. Alrighty. So all it is a conversion. It's a mathematical construct which allows you to compute, instead of simultaneous equations, like 2 of them, you can compute 1,000. Imagine doing 1,000 simultaneous equations all at once by hand. You would not be able to do it, so you create a matrix. You're trying to learn integration. Oh, well, you'll definitely want to see my my integral calculus episodes before that. I'm going to do a proper calculus course. Where would you get those equations from? They would be given to you, like, so I'll show you. If you look at this phone, right? This phone is represented by 4 equations. Oh, welcome aboard, my friend. All right. So I need more Patreon. Once I get more Patreon, mathematicians love these curly brackets. That's so true. When I get more Patreon subscribers, I won't have to work every day, and then I can do more maths when I can. Oh, thank you, Dumonu. That's a pleasure, man. You might like my astrophysics and astronomy lectures and ethics lectures because I have less mathematics in them. All right. So here is one of the equations, right? This equation, it represents this line. Another equation is this line. Another one is this line. Will you show more matrix maths? I will, but it's not my core at the moment because I just don't have enough time. Because I have to work every day, unfortunately. But we're building up. I think at the moment on Patreon, I've got like 50 subscribers a month. Once I get to 2,000, I'll be able to I can work like only a couple of days a week, and then I can just do maths like every other day, which is the plan. Because at the moment, I have to tutor people one-on-one, and it's sort of inefficient because, like, you know, you're charging people like 50, 60, 70 bucks or whatever it is for, like, you know, an hour. And I enjoy it and they enjoy it. It's great. But imagine with Patreon, like, everyone pays $1 or $2 a month, and I can then help thousands of people, and it's heaps cheaper. Like, that would be amazing. But we'll see. We'll get there. Who knows? It may not work. All right. So that's the 4 equations, right? Here's one equation. Differential equations. Yeah. Here's another one. Here's another one, and here's another one. These are 4 different equations, and then what they would do is they would actually make up this plus a 4th one. And then you put that into a matrix, and then you could find the area, you could rotate it around, you could do heaps of stuff. You know, you could find out what would be the best way to structure the phone to get the maximum heat dispersion, the maximum magnetic flux. You know, it's amazing all the stuff you can do with matrix algebra. In fact, Isaac Newton, since you can replay them. Yeah. Well, what I do, I repost all these videos, I repost onto YouTube at Gabsmacked. You could find that area with the determinant. Exactly, my friend. Numbers are abstract to me. Yeah, it's definitely abstract, that's for sure. Yeah, you can find the area, and what you could do is you could find all possible areas, right? Sorry, you could find all possible shapes of that phone with the same area. So let's say that, like, you know, the company says to you, you have to make the phone this area, right? Now you have to figure out which area, which shape to make it to disperse as much heat so the phone doesn't overload, but at the same time, it can't be ugly so that people don't buy it. And the company, you know, and you got to work out all these different shapes, and the computer does all the matrices, right, for you. And you can bend it and twist it, and you can have curvy edges. And were you always good at math? No, I failed math in school because I was a very troubled student, and I had pretty bad autism back then. So I've learned to deal with it. I went back to university at 33, and I topped the uni. Well, yeah, I got like high distinctions the whole way through, basically. It's not a gift. Yeah, it's probably a combination of the two, but you can definitely be good at it. You can definitely be really good at it, irrespective of whether you can be very talented or not. Anyway, that was my introduction to matrix algebra. Hey, God's dead, welcome aboard. And I am now going to go back to the GabSmack channel and talk about autism for a bit. And then I'll come back here and do some quantum mechanics. But if you want, you can see the ethics stuff. I'm going to be doing climate change as well today. That's going to be awesome. We're going to trigger so many people on both sides. It's going to be really fun. All right, that was Gabversity, where facts don't care about your feelings. Gab Unsmacked. Oh, Gab Unsmacked. I'll add you to Gab Unsmacked. You're welcome, George. Great to meet you guys. All right. Hey, Captain. That's true.